Hey YouTube, what is going on? Thanks for checking out the Straight SRT8 YouTube channel where we discuss all things SRT8 related. Now today's presentation will be another video in the Knowledge Drop series. This is going to focus on battery fundamentals. So this is going to be a building block to my previous video where I covered the basics of electronics. If you haven't seen it yet, go ahead and check it out. I'll put the link here in the video. But moving on to batteries, I want to discuss the core fundamentals of batteries. So I want to get into battery terminology and basics. How do batteries work on a very fundamental level, and then get a different terminology. The terminology also incorporates standardized testing to compare different batteries across multiple manufacturers. These are a great way to compare apples to apples comparisons and to kind of wipe away and do away with all the marketing information for strategic words they use to help persuade a buyer to choose one battery over another. So the standardized testing does away with all of that and creates a great comparison table to build different comparisons across batteries. I want to get into pros and cons. All batteries have their pros and they all have their cons. I want to get into what those are to make us more aware, to make us more of a well-rounded user. Specialized batteries. I am going to talk about marine batteries. I'll talk about electrical vehicle batteries, talk about phone batteries. Quickly divert from the automotive world and explain why they are not used in automotives, and then get back into the automotive world covering AGM, which is absorbed glass matte batteries, and flooded lead acid batteries. Those are the two most typical commercially available batteries that exist today. I'm going to get into battery maintenance. Some things you may or may not know about your batteries in your vehicle and how to properly maintain them. Get into battery buying tips, the tips and tricks I use to buy batteries and compare them from manufacturer to manufacturer. I'm actually going to walk through what I've done in previous vehicles that I purchased and how I've gone ahead and assessed those batteries before purchasing them. And then get into a general battery FYI. This gets into just general knowledge on how to maintain your batteries the best way, how to ensure the best life out of batteries, and how to make sure you're getting the best bang for your buck. That being said, first topic, battery basics. So batteries on their most fundamental level convert chemical energy into electrical energy. This is done through two main commercially available methods, through a flooded lead acid battery and absorbed glass matte battery. So on the screen right here, we have a typical battery. This is a flooded lead acid battery. This has an outer housing in plastic, which has a positive and negative terminal. And then inside there are these different plates. We have positive plates and negative plates, and between them is a separator. And these plates are made out of lead. And that lead allows for the movement of electrons through the negative to the positive terminal. And then for a flooded lead acid battery, the entire battery is submerged, or is quote unquote flooded, typically in a distilled water base to allow for the electrons to move through the negative to positive terminals. In an absorbed glass matte configuration, there are quote unquote dry build instead, and in between the layers of your lead, you have more like a fiberglass mesh, and that is used to help, again, move electrons from the negative to the positive terminal, provide power to the car. Now, both these are commercially available, and they're going to make up the bulk of what we talk about today. Both of them, though, are dependent, their efficiency is dependent on temperature. As batteries, and all batteries, not just these ones, as they get colder, they become less efficient. This is why electrical vehicles have less battery life and less mileage per charge when it's colder out, and they do better when their batteries are actually warmer. So getting into some terminology. The point of this terminology, again, is to make sure that we understand the standardized tests to compare different manufacturers and a good apples-to-apples comparison. So cranking amps are important for people whose batteries are going to be above freezing temperatures. So for those of you who do not have to deal with very, very cold sub-freezing temperatures for winters, you want to focus on cranking amps. And that defines how much a brand new fully charged battery can deliver at above freezing temperatures while maintaining a minimum voltage. This test is then repeated again for cold cranking amps. So this is for the same test but performed at sub-freezing temperatures, which is specifically 0 degrees Fahrenheit or negative 18 degrees Celsius. So cold cranking amps are always less than cranking amps because batteries get less efficient as they get colder. So comparing cranking amps and cold cranking amps to different manufacturers is a great way to understand how much internal power these batteries can provide in different conditions. Now, the voltage is another important measurement, but all batteries are typically tested to and fully charged at around 12 volts. Now, more often than not, they're actually fully charged at around 13 volts. And then while you're charging your battery, you're actually going to be supplying about 14 volts to it. This is through your alternator to ensure your battery is fully charged. But the nominal voltage is inherently 12 volts. The amps, or the current, is a measurement of how much energy the battery can maintain and can provide to your starters and different requirements in the vehicle. But this is again defined as either cold cranking amps or cranking amps. Then we get into battery sizing. So battery sizing isn't important in today's cars because the OEMs, the original equipment manufacturers, specify how much power is needed for a certain car. So when you go on a website of, say, Advanced Auto Parts and you're going to buy a new battery and you want to use a diehard battery, they're going to tell you the one that's required for your car in order to meet or exceed the requirements of the OEM. This is typical for every battery manufacturer. Whether you talk about diehards, you talk about Odyssey batteries, or even Optima batteries, they are all sized based on the year, make, and model of your vehicle to ensure you get the proper battery as a replacement to your original equipment manufacturer's battery. However, in order to get a more basic understanding, as engines get larger, they have more internal resistance, which means they need more power to start them and turn them over. So typically, you want one cold cranking amp per every cubic inch of engine. So for our SRTs, for the 6.4 liters, we have a 392 cubic inch engine, so you need about 392 cold cranking amps, typically, to provide power just to start the engine. This doesn't include a safety factor. It doesn't include extra capacity in the battery for auxiliary requirements too. But this is just a very rudimentary sizing method. Then we get into reserve capacity. So reserve capacity is really designed to let you know how long your battery can power your car if your alternator were to die. So this test requires that on a fully charged battery at 25 degrees Celsius, providing a current of 25 amps before dropping to 10.5 volts, a nominal voltage. So this is really to make sure you have extra capacity in the battery once you start your car to ensure your battery has an additional capacity in there as needed. This is pretty important to make sure that your battery can sustain the starting of an engine without immediately dying and has enough power to continue on with the vehicle's needs. And then finally, we get into battery life. So battery life typically is between 3 to 5 years, but it's very, very dependent on the user and how they operate the battery. So factors such as auxiliary loading, and by this I mean if you have a radar detector, if you have a dash cam, you got a sound system, battery chargers, you name it, those are auxiliary loads in the car that weren't there at the inception of the vehicle, so they weren't in part of the OEM's calculations for power draw. Driving duration. The longer you drive your vehicle, the more charged the battery is going to be. For shorter, quick bursts, you're going to have a huge drain on starting your car. And if you drive it for a minute, then that drain cannot be replenished through charging, and your battery is actually going to be a little bit less voltage. And as you keep starting it and doing it again and again and again, eventually you're going to deplete your battery and cause internal damage to that battery. And then, of course, as we talked about previously, outside temperature has a big impact on the efficiency of the battery. So all these things add into battery life. That's why I say typically it's between 3 to 5 years. If you're driving in warmer conditions and you do longer hauls of the car, you're going to have longer battery life. And if you're driving in very, very cold temperatures with short bursts of driving, you're going to have less battery life. So now typical pros and cons for all batteries. So a great pro is you have on-demand power. I mean, we can convert chemical energy into electrical energy on batteries. It's an awesome technology, very, very useful, especially obviously for starting cars. The new AGM, absorbed glass mat batteries, do not require quote-unquote regular maintenance. Now, flooded lead acid batteries do require maintenance. AGM batteries do not. I'll get into this a little bit later on in the other slides. They have good power density. Not great, but good. When you compare this to the power density in gasoline, it is much, much higher in gasoline. That's why the gas tanks for cars are much, much smaller in comparison to the battery sizes for electrical vehicles, because there's much more power contained inside gas in the same per square inch area as comparison to a battery. However, battery technology is constantly evolving and constantly getting better and better and becoming more and more dense. I'll explain later on as to a new technology that's in the market that's going to even further improve that. That all being said, batteries can be connected in series or in parallel to produce the desired voltage or current needed. So let's say you need a 24-volt battery. You can put two batteries together in series and boost your voltage from 12 volts to 24 volts. Or let's say you need 12 volts, but you need double the current. You can put two batteries in parallel and have your same voltage at 12 volts, but have twice the amount of current delivered. So very, very flexible in terms of being able to stack batteries in different configurations to get the required voltage and current output. Now some negatives. All batteries hate being discharged very quickly. They're not designed for it. That's why EVs have these massive batteries, because at a high discharge rate, in comparison to the battery's capacity, it's very, very small. If you were to try and discharge a very small battery very fast, it would permanently cause damage to the battery. That'd be irreparable. Temperature. We know temperature affects battery efficiency. As it gets colder out, batteries are by nature less efficient. Maintenance. There is still some maintenance required on batteries, even those that say they do not require regular maintenance. I'll get into this later on, but certain batteries, actually all batteries, are going to require a constant charge to make sure they do not dip below a minimum voltage threshold where they can become damaged. And then battery life, as I mentioned before, is dependent on usage. So automotive batteries aside, let's get into specialized batteries. So one specialized battery is a deep cycle marine battery. They're either referred to as deep cycle batteries or they're referred to as marine batteries. These ones are designed to discharge most of their capacity before requiring a recharge, and they do not damage the battery in doing so. However, this is not a good case for typical car batteries. Car batteries cannot be discharged almost all the way marine batteries can. Marine batteries are designed to provide power to start a yacht or a boat's motors or engines, and then provide power for a sound system, powering a fridge, powering lights, whatever it may be, and then being recharged when they are returned to port. Car batteries are not designed to do that, and thus should not be used for this. Otherwise, you can cause damage. Also, marine batteries are not designed to be constantly discharged and recharged and discharged and recharged like car batteries are. So you cannot put a marine battery into a vehicle and vice versa. They're just not designed for it. Lithium batteries. These are a huge new technology, probably one of the most mainstream technologies out there. Lithium polymer batteries that are used in electric cars and they're used in cell phones. But they're not used in car batteries. Well, why not? They have these great abilities to maintain constant voltage through their entire discharge range. However, they are expensive to produce, very expensive actually for a vehicle, and require special circuitries. These batteries cannot be discharged too fast, they cannot be discharged too low, they cannot be charged too fast, and they cannot be overcharged. So they have a lot of special circuitry required just to monitor the batteries themselves, which adds to the cost of batteries. So it'd be cost prohibitive to have it inside of a vehicle. Gel batteries. These are highly efficient to charge, meaning the more power you put into them, more of that unit of power gets transferred to the battery and absorbed by it and isn't lost. However, they're easily damaged by vibration or by overcharging or by fast discharging, so that makes them not very ideal for vehicles. And then lastly, we get into graphene batteries. Now, I believe graphene batteries are going to be the new standard for batteries going forward. They have improved battery density, which is phenomenal. They can be discharged and charged much, much faster, and because of that, they offer better battery life. Now, this may be the future batteries, but right now it is not commercially available. It's still going through R&D. It's still very, very expensive and cost prohibitive. But eventually, like all things, they're going to become cheaper and cheaper to mass produce, and eventually, I believe graphene batteries are going to be the next generation of battery technology for internal combustion engines and probably for electrical vehicles as well. So now I want to get into AGM, absorbed glass mat versus flooded lead acid. Let's get into the definition of both, some pros and some cons, to determine what is best for you. So flooded lead acid batteries, they are the most traditional battery form that exists. They are wet or they are quote unquote flooded with a liquid. In most cases, it is using distilled water. But through their use, they have off-gassing, which means they emit gases from the battery, which means that the water eventually starts to dissipate and needs to be replenished. So if you guys remember way back when, we had to constantly add more water to our batteries to make sure they had proper levels of water inside them. This is an issue with flooded lead acid batteries. They also are more easily damaged. When it comes to violent movements or vibrations, the plates in the batteries can begin to become brittle and start breaking down. As they break down, you lose surface area, which means you lose electron movement, which means less voltage and less current provided by the battery. So over time, especially in vehicles, think about those are like ATVs or off-roading vehicles. They have a lot of inherent vibration in them, which causes damage to the battery. which causes your battery to wear down very, very quickly. One of the pros, though, is they're cheaper to produce. They've been around for a long time. It's old technology, and it's cheaper to produce them. So in comparison to absorbed glass mat batteries, which are the new standard batteries for combustion engines, and these batteries have that fiberglass mesh, which offers a dry solution in comparison to the wet solution found in flooded lead acid batteries. Because they are dry, they are considered to be maintenance free. This means they have minimal off-gassing and they do not require replenishing of water, which is awesome. Virtually maintenance free. I say that because they still require some maintenance. When it comes to any battery, you want to make sure it has a constant charge, especially when you're storing the vehicle, which I'll get into in my next slide. But there is some quote-unquote maintenance involved for different types of batteries. The AGM batteries do not want to be fully discharged. So for those of us who go to car meets or car shows and we're powering lights, maybe LED lights, maybe we have a sound system going, it's a good idea to make sure your car is running every now and again to recharge the battery to make sure it's not being depleted. When you deplete your battery too much, you cause permanent damage to the battery. And if it's already depleted, and you try and have a giant power surge, like starting an engine, on a depleted battery, it will cause permanent damage to the battery. So it's very, very important to make sure that we do not deplete our batteries less than 50% for AGM batteries. And to be safe, I'd go much, much higher than that, just to make sure we're never in that danger area. Now, one of the cons for absorbed glass in batteries is they're more expensive. They are new technology, and as such, they cost more, and they're going to be less budget friendly, but they are going to offer a more robust battery in exchange for that price. So battery maintenance. Now, this is where I talked about in previous slides where there are some maintenance involved in batteries, and there is maintenance involved in all batteries. This comes in the form of electrical maintenance, though. So for long-term storage, batteries have an inherent internal resistance, which means in between the negative and positive terminal, there is a very, very small resistance. However, over time, that resistance is going to eventually drain the battery, which means if you leave it alone and you don't put any kind of charger on it, eventually it's going to get very, very discharged, and it's going to start damaging itself. So they sell special chargers called trickle chargers that are designed to maintain an optimal battery voltage, the way they do not become depleted and become damaged. So if they are on the ground, they actually have a higher resistance because the ground starts pulling some of the energy out of the battery into the ground. So never have a battery on the ground. Always keep it on a shelf somewhere. And make sure you always charge it with a trickle charger. And then if you have a flooded lead acid battery, again, periodically make sure you have proper water levels in there so you don't have the battery becoming dry and then again becomes damaged and irreparably damaged and permanently damaged. So when it comes to storage, some people, they drive their sports cars in the summer and let them sit in the wintertime. If you're going to do that, you can leave the battery in the vehicle. It's not a problem. Just make sure you attach a trickle charger to the battery. Again, when your battery is in your vehicle, it's going to draw standby power. You're going to be powering your CPU. You're going to be powering your alarm system. Your car is going to have this inherent power draw from your battery. So you make sure if you're keeping it inside your vehicle that you always attach a trickle charger to it to make sure it stays charged. If you're going to need the ability to unlock your doors and lock your doors and roll your windows up and down, make sure your battery is obviously in your vehicle and attached to a trickle charger. If you don't care about any of that and you plan on having your car be stored in storage, you can remove your battery from your vehicle and go ahead and put it on a shelf and attach your trickle charger to it. It's a little more work, but if you don't need access to your vehicle, it's another option as well. So some quick tips. You want to minimize any significant power draws on your batteries. Now this doesn't matter if you have an AGM battery or a flooded lead acid battery. You want to minimize those significant power draws. That again can be if you have a sound system with subwoofers. Subwoofers draw a ton of power, and a ton of instantaneous power at that. So by having that constant power draw on your battery, it's going to eventually kill your battery life and cause a reduction of battery life. You don't want to allow your battery to become too discharged. Again, if you're at a car meet and you keep starting your engine and turn it off and start your engine and turn it off, or you're powering using power converters or inverters, you're powering a PlayStation and a TV off your car battery, it's going to discharge your battery and eventually cause damage to that battery if it gets discharged too low. And then again, you want to minimize constant power draws. So you can imagine your vehicle is in sub-freezing temperatures. You're powering a radar detector, you're powering your dash cam, maybe you're powering your phone, so you're trying to charge it. You've all these loads in your battery, plus trying to start it when it's freezing cold outside. That can cause your battery to not have enough power to properly start your engine. And if that happens, you can cause shorting inside the battery, where you draw too much power, but it can't provide it, and you cause internal shorting or arcing inside the battery, which causes permanent damage too. So try and minimize those constant power draws when your battery is not fully charged. So now I want to get into battery buying tips. So there are 3 main battery manufacturers that I've used in my past that I like to talk about and describe their uses. So I want to get into Optima batteries, I want to discuss DieHard batteries, and I want to talk about Odyssey batteries. So starting with Optima batteries. They were purchased by Johnson Controls in the year 2000. They use a quote-unquote spiral cell and pure flow technology. This, they claim, has superior vibration resistance and allows for easier current flow through the battery. There are 3 main types of batteries from Optima. You can get the yellow tops. These are designed for typical compact cars. They have their red top version, which is great for vehicles who require more power, such as SUVs or trucks. And then they have their blue top, which is their marine deep cycle battery. Optima batteries used to be excellent. They used to be phenomenal batteries. But recently, their quality has dropped, and because of that, the prices have increased quite a bit, actually. I actually owned a Optima yellow top battery many years ago, and I used it while having a 1,000-watt subwoofer sound system. Never had a problem with it. It always started my car without an issue, even in freezing temperatures, even when I had my sound system going too. However, now due to their quality issues, I would not recommend purchasing a new Optima AGM battery. They can be hit or miss. I know when they're good, they're great, but when they're bad, they can be pretty bad, unfortunately. Now we have DieHard batteries. I did purchase one of these from Advanced Auto Parts, and they are one of their major brands. I purchased the Platinum version. This has their stamped grid technology, which provides a stronger, more durable battery, which provides resistance to vibration, which then equates to better battery life and more power for starting a car. These are designed to meet or exceed all manufacturer requirements, as are the other 2 brands in here. I did actually own a DieHard Platinum AGM battery. It worked great in the summer months, but during the winter it was constantly being shorted out during my starting of my SRT. I mean, one day I would drive my SRT, I'd park it in the garage or park it outside, get home at 5 p.m., start at 7 a.m. the next day, and it would short out on me. So I had quite an issue with these batteries. However, many subscribers and viewers have had the same battery for many years without issue. So because of that, I'm assuming I had a bad battery, and I would consider purchasing this battery again. So it'd be my second choice out of the 3 brands, but my main choice would be the Odyssey batteries. I have one right now. And Odyssey makes 2 different forms of batteries. They have their performance version and they have their extreme version. The extreme version is physically bigger and has more capacity. This is designed to offer more than you would typically need for a typical person. This is a great option for those who have auxiliary power needs. So if you're one of those guys who goes to car meets and has a big sound system, and you want to have the ability to power a TV off of your car or an Xbox or anything like that, these Extreme Series batteries will be an awesome asset for you, but they are physically bigger. Just keep that in mind. Now, one of the technologies for Odyssey is their thin plate pure lead technology. Other manufacturers use recycled lead, which isn't 100% pure or 99% pure. The Odyssey batteries are 99% pure virgin lead, which means they have thinner plates, which means they have more plates, which equates to more surface area, which means more power to generate. This does, however, come at a higher manufacturing cost. Using virgin materials costs more money than recycled materials. There is a little bit of a cost offset there. I do currently own a performance version of the Odyssey battery and had 0 issues with it. I've had my car started in 9-degree temperature, so not quite 0 degrees, but it is considered freezing, and I never had an issue. My car started up perfectly fine, never had a problem charging or discharging. One note worth mentioning though, the extreme version of this battery, I actually wanted to buy it, but it physically will not fit in our SRTs, especially for the WK2 Jeeps. It may fit in other SRTs. I'd be surprised if it did, but it definitely would not fit inside WK2 Jeep SRTs without modifying the vehicle itself. Now my last slide, actually I lied, my second to last slide, is general tips. So when it comes to buying a battery, what should you look out for? Well, it really depends on what your individual needs are. So If your budget allows, always buy an AGM battery. They perform better. They are more vibration resistant. They offer better battery life. They offer more cold cranking amps than more cranking amps. They are just a better overall battery in comparison to their counterparts, which is the flooded lead acid. Now, let's say you can afford AGM batteries. What should you focus on? Well, if you live in an area which is very cold, I'm thinking like New York, then you want to focus on having the highest amount of cold cranking amps possible. So keep in mind that when you buy a brand new battery, those specs for cold cranking amps are on a fully charged brand new battery. Over time, every battery becomes less and less efficient, no matter how well you maintain them. And so as you get older and older and older in the battery's life, they become less and less efficient at delivering those cold cranking amps. So by making sure you have the highest amount possible at the beginning, we'll ensure your battery has enough power to last you through the most amount of winters possible. If that's not an issue for you, if you have an area or live in an area that's always 32 degrees Fahrenheit or higher, then I would focus on cranking amps, not cold cranking amps. Typically though, those go hand in hand, but with higher cranking amps means you're going to have extended battery life. So you want to make sure you're maximizing battery life in those conditions. Again, it depends on what your uses are for the battery to help extend battery life, but I'd focus on the higher cranking amps or the highest amount of battery life possible for that specific battery brand. Lastly, if you require a constant auxiliary power source, so again, focusing on radar detectors, dash cams, so on and so forth, then the Optima Extreme series is a great option because it has that inherent built-in extra capacity. So for my three manufacturers discussed here, the Odyssey, the Diehard, and the Optima, I ranked my favorite one as the Odyssey. I've had no issues with it. The Diehard I ranked second based on the viewer subscription and comments. And then thirdly, I'll put Optima. I may even put Optima behind other manufacturers as well just because of their quality issues. So the last slide is battery FYI. It's just a battery knowledge dump in general knowledge on batteries. So as I mentioned before, keep in mind that batteries lose capacity over time. As they get colder, they become less efficient. And as they get older, they become less efficient. So the worst case scenario is a cold, old battery. So that's going to give you the hardest time trying to start your vehicle. So constant surge loads. I'm thinking about, again, like non-factory subwoofers. They're going to have negative impacts on battery life. When your OEMs determine the load or the size of the battery, it was based on load. It's probably based on your cold cranking amps plus some safety factor. They did not include the needed ability to power subwoofers or LED lights or HID lights or whatever else may be inside your vehicle. So if you're having a hard time starting your car, try and remove those auxiliary loadings in order to make sure your battery has the most amount of power dedicated just towards starting your car to ensure the best amount of battery life. Now, constant engine starting on discharged batteries is going to have a huge impact on battery life too. Think about your Amazon driver who starts the car, drives a few feet, stops, drives another 10 feet down the road or 20 feet to the next house, turns it back off again. They are constantly having this huge power draw on this battery. In those short bursts of driving, there's not enough time to actually recharge the battery. So overall, the battery life begins to drop again and again and again, and your voltage continues to drop, potential continues to drop, and eventually your battery life is going to be very, very short in comparison to how it should be. So make sure that when you drive your vehicle, if you can, try and have your battery, give it decent time to recharge. Try to minimize those constant impacts on the battery. For those who have sound systems, again, having that constant barrage of power draw on the battery is going to cause damage to the battery too. There are other ways around it besides having and relying on your car battery. That'll be safe for another video though. If the battery is near end of life, so you've had your battery for your 5 years and it's freezing cold outside and you need to start your car, there is an option to be used in emergency situations. So a lot of car battery chargers have built-in capacitors or have a built-in battery. And those can be used to start a car. They can be used as a jumper. Now, of course, the manufacturer must specify it can be used for such. But I know for a fact the battery charger I have does have the ability to provide up to 100 amps to help supplement the battery during an emergency jump start. So in case your battery is already towards the end of life and winter's coming up, which we are in the middle of winter right now, and your battery's acting iffy and you can't afford to buy a new one, If you have a battery charger that has the ability to jump a car, make sure that is always kept with you and kept fully charged. That way, in case this emergency situation happens, you have auxiliary power there to help start your car. Now, installing batteries. Most stores will install the batteries for you for free. If you go to Advanced Auto Parts or you go to AutoZone or CarQuest, they will install the battery for free. For the Jeep SRTs, they will not, because it is considered to be a complicated installation. It involves moving the seat and moving some paneling, so they won't install it for free. If you do it yourself, take extreme caution and make sure you always keep your negative and positive terminals covered. The worst thing you can do is touching your negative and positive terminal together. That'll cause a direct short, and whatever your cranking amps are, it's usually hundreds of amps, will be put directly across those terminals, which can cause a fire, it can cause an explosion. If you touch it, it can cause you to be electrocuted. So always keep your covers on your positive and negative terminals during installation, and only remove them when you're actually ready to tie wire them to the vehicle. Now, if you have questions on that, I have a video on how to install a battery in a Jeep SRT, so go ahead and check that out. That being said, that is the end of this presentation. I know it's pretty lengthy at 31 minutes. If you guys got questions, go ahead and throw them below. I'm going to put my battery charger I use below in the description, and I'll include cards across the video to make sure you guys can have the easy way to choose my battery installation videos as well as previous knowledge drop series videos as well. That being said, though, if you guys got questions, again, as always, drop in the comments below. I look forward to talking to you guys. And I'll see you soon. Thanks.